here. This video lecture is in technical mathematics. It is one of several done for technical mathematics. This video lecture is on the law of exponents. There are three corresponding videos that work with exponents and radicals that you can view at a different time. Let's talk about exponents. Here are some rules for exponents that you should be pretty much familiar with, but we'll try and talk through them. When you have a variable raised to the m exponent and a variable raised to the n exponents, so we're multiplying them, we add the exponents. When we have a variable with an m exponent raised to the n exponent, we multiply the exponents. And when we have two variables raised to the n exponent, we can raise each one of those variables to the n exponent, and it will be the same thing. Now what about dividing? Here we have those two variables again, only they're in a division, and they're raised to that m exponent. Again, you can break them apart and raise each one to the exponent. Let's take a look now at when there are two different exponents. So we have the variable raised to m and the variable raised to n. What we do is we take the variable and now we subtract the exponents. I'm going to get into this a little bit later, and I'm going to term it a little bit differently that may simplify things for you. Okay? Anything raised to the 0 exponent is always 1. Now what about if we raise it to a negative exponent? When we raise a variable to a negative exponent, that exponent becomes positive in the denominator. So in other words, we flip this into the denominator. And we'll be talking about that. Okay, let's go on. Okay, here we have two new rules for exponents with radicals. Okay? That's what we're going to be working on in this video. We have b raised to the 1 over n. This is a fractional exponent. When we have a fractional exponent, we can work with that by putting in the radical sign. And the variable becomes what we call the root, or the indice. And then the variable stays within the radical. So we can easily take a complicated fractional exponent and change it into a radical. Now, what happens, again, we talked earlier about when we had a variable divided by a variable, two different ones. This would be like maybe 2/3. Okay, what do we do with that? It's actually b to the exponent m, which we could say was our 2. Let's put that down here. b to the 2. Let's put what we started with so we don't forget that. Okay, we're going to say b to the 2/3. Now, that's b to the 2 raised to the 1/3. Alright, we changed that into a radical. And what it becomes is our b to the 2nd remains underneath the radical, and this becomes our root, 3. So we can change even a very complicated exponent into a radical, and we could solve that way. Alright? How about a real problem? 125 raised to the 3rd. Let me okay. Now, first of all, we know that this fractional exponent we can turn into a radical. Now, how does that work? their radical. Now we have the 125 underneath the radical, and it's not really raised to anything, but we can put this 1 here. Anything raised to the 1 is the same. But we can put that 1 there so that we can see where it belongs. And this, the denominator, becomes the root. Okay? So it's the cubed root of 125. And if we solve that a little further, we can determine that the cubed root, how many times, if we break that up into 5 times 5 times 5, we have 3 5s. Therefore, we can take that 5 outside the radical. So the cubed root of 125 is actually 5. Okay. Here's another one. Now, in this case, we're going to talk about that radical that is 2 different numbers in the denominator and the numerator. So this is -8. Let's put a radical sign because that's what we're working with. And we're going to put our -8 down here. Okay. Now this part, the numerator, comes underneath the radical. And this denominator is the root. So we've rewritten that as -8 squared and the cubed root of that. So tell me, what can we multiply? We can multiply again -2 times -2 times -2. Now, actually, we still have this squared to worry about. Okay. So let's just change this a little bit, and let's put this squared on the outside. That'll help us a lot. We don't want this in here. So taking out the cubed root of -8 would actually be -2. So we have -2, but we still have that square on the outside. So the actual answer becomes 4. And in another video, we'll treat this negative underneath the radical sign a little bit differently. But for now, since we're talking about exponents and simple radicals, we'll just leave that -2 and we'll carry it. Get the idea? Here's another one. 64 to the -1/3. All right, now immediately, see this negative sign? We don't want to work with that, okay? So we want 1 over 64 to the 1/3. So see, we did the inverse of 64, 1 over 64. But we still raised it to 1/3, but now it becomes a positive 1/3. Okay, we should be getting better at this. We can rewrite that into a radical, right? We've got 64, and we've got the cubed root. Okay, still carry your 1. Anybody know what the cubed root of 64 is? Let's see, 4 times 4 times 4, that equals 64. So I'm not going to write that out this time, but I think you're getting the hang of working these out. Okay, here we have 1 over 25. Oh boy, raised to the 3/2. Let me get a pen. Now, what are we going to do? Write our radical, and we've got 1 over 25, and this 2 is the same thing as saying the square root. Usually when we use the square root, we don't put the 2 there. I think you've seen probably before, this is the most popular format, it's the square root of a number. So we won't put that 2 there. However, we still have to put our 3 down. And remember, we decided that if we put this 3 outside the parentheses, that it made it much easier for us. All right, what is your square root of 25? 1/5, right? We still have that cubed, so that should equal 1/125. I just cubed that 5. All right. So if you remember on these, when you have a exponent that has 2 variables in it, you want to just put that outside the parentheses. It looks a little bit easier that way. Ready? Try this one yourself. Stop the video, try and work this out, and once you've got it done, take a look at problem solutions under that tab in the website. Here's another one. Now this one's got a double variable here. All right, let's go on to working a little bit with just exponents now that we've got where to put them in radicals, and we'll come back to that. Okay, remember the rules for exponents. Let me see if I can bring that up again. There it was. Remember the rules for exponents? When we had bm times bn, it became plus. So when we multiplied them, they were added. When they were raised, it was multiplied. We can separate them, or we could separate them in division. Now, let me see if I can go back to that problem we wanted to work on. Here it is. So here we have 2 items, and we're multiplying exponents. Now, what did we say when we multiply exponents? Ugh, having a little trouble getting my pen here. Let's try that again. This is the slide we want to work on. We would have x, and what would we do with those exponents? We would add them, plus -2. So the answer to this would be x to the 6th. Right? Now we're dividing by. And remember, I told you I would try and simplify this for you. Okay, well, I have this funny little rule that I call put where the most is. Doesn't that sound crazy? Okay, let me explain it a little bit first. We have 3 here, and we have 12 here. If we take this 3 and we simplify it, and we take 3 out of here, what do we have left? 9, right? So we take 3 A's out of here, and we take 3 A's out of here, and what we end up with is A to the 9th. Now your rules said things about subtracting these, and then you may come up with a negative and you don't know what to do with it, and then you have to switch it. Remember that tiny little crazyism I said? Put where the most is. So the most is in the bottom. Take out 3, simplify this to A to the 9th. All right? All right. It's your turn. Stop the video and try and do this problem. When you're finished, take a look in problem solutions. Here's another one. This is division of exponents. All right, here we go. This is what we wanted to get to. Now, what do we do when we have b to the 2/3 times b to the 1/4? Didn't we say that we added those exponents? So we have b to the 2/3 plus 1/4. All right, now we're going to go back to those old days. Remember how we add fractions? We have to have least common denominator. Remember that? And the least common denominator equals 12. So in order to add these, both denominators have to be 12. So let's change them over. To make this a 12, I have to multiply by 4. So that becomes 8/12. To make this a 12, I have to multiply the top by 3. Actually, I'm multiplying both of them by 3. 3/12. Now I can add them. Okay, since we're just working with exponents, we won't change that into a radical. But I think you know how to do that. Okay, let's keep going and work a little bit more with exponents. Here we have a lot of exponents. But let's rewrite this. And when we raise something, remember we distribute that in. So let's rewrite it so it's simple for us. N to the 7th. And we'll have that over. Now, what do we do when we take an exponent and raise it to an exponent? Right. We multiply the exponents. So 2 times 3 is 6. And that n is raised to the 1st, so 1 times 3 is 3. Okay, you know my rule. Put where the most is. This simplifies and cancels out. We have 3 n's here and 7 n's here, so we're going to take out 3 and we're going to reduce this to 4. We're going to take out 3 up there. So what is our answer? N to the 4th. Isn't that great? This complicated exponential fraction we reduce down to n to the 4th. Now, if we were working with equations in engineering or any type of technical studies, bringing that equation down to n to the 4th would certainly help our process. All right, here's one for you. You try this. Now remember that this is fractional, and you have a 2 actually over 1 and a 2/3. You're going to bring those out and you're going to make them least common denominator for adding them. So just a little tip. Stop the video, solve the problem, and take a look in the tab for solved problems. Here's another one, similar to what we did in the video earlier. You have a couple of variables up here, and then you have these variables raised to a variable. What you're going to do is distribute that variable in to all these. Distribute the exponent into all these variables. Okay? So stop the video and try that. All right, hope you got through those 2 problems. We're getting a little more complicated now. Let's see how we would do this one. All right, first of all, we're going to bring those exponents into the problem. So we have x to the 1/3. Let's just write that out and see what it looks like. X to the 1/3. I'm going to get this a little heavier so you can see it. X to the 1/3 raised to the third, and y to the third raised to the third. And then we have y to the 10th raised to the 1/5, and x to the 5th raised to the 1/5. All right, now we've got it all spelled out in longhand. Now we can simplify that. X to the 1/3 raised to the third, that makes it 1. So we're going to put down here x. Y to the third raised to the third. What do we do when we raise an exponent to an exponent? We multiply them. So this will become y to the 9th. Here's y to the 10th raised to the 1/5. That becomes y to the 2nd. And x to the 5th raised to the 1/5 becomes x. All right? Okay, now I've got a simple problem, but we're not done yet. Remember, we have to put where the most is. Thought we were done, huh? No. So we cancel out the x's, and again we have 2 y's down here, and we have 9 y's up here, so we'll take those 2 out and we'll change that to 7. So our answer is y to the 7th. Okay? Okay, I think this is our last one. I'd hate to get more complicated than this, right? All right, let me get my pen. And we'll say, first of all, we've got these negative exponents, and we just do not want to work with negative exponents. So the first thing we've got to do is turn them around. And that whole thing is raised to the second exponent, okay? And here we've got a negative 2. Remember, see how we changed this to a positive? We inverted it and changed it to a positive. Well, we're going to do the same thing with this one. A to the 6th raised to the 4th. All right, now, what are we going to do with this? Let's simplify it out. We have 6 squared, and we have b squared over 5 squared. What is a squared raised to the squared? What do we do when we raise an exponent to an exponent? Multiply them, right. So this will become a to the 4th. Don't let that trip you up. Okay, we're still multiplying. We've got a to the 4th over 6 to the 4th. Okay, we can simplify this. We have 4 a's here, and we have 4 a's there. That did a lot for us. Okay, now, all right, now we're still putting where the most is. So we have 2 6's here. And we have 4 6's here, so we're going to change that to a 2. And we have 5 squared here. So let's put what we have left over. We have b squared, and we have 5 squared times 6 squared. All right, that's going to still give us the b squared. We'll probably have to use our calculators here. 5 squared is 25, and 6 squared is 36. We multiply that out, and we end up with 900. So again, look at where you've come from. This complicated fraction raised to negative exponents, and we've brought it all the way down to b squared divided by 900. All right? This concludes our tape. Hope you enjoyed it, and we'll see you on another video.